Hello again, welcome to another lesson in geometry. Today we're covering section 7-5, proportions in triangles. All right, so vocabulary, we've got some review here. Circle the model that forms a proportion with 10/15. So this ratio 10 to 15 reduces to 2 to 3, so we're going to use that. That's probably easier for us to work with. This one becomes 6/8, the blue ones to the whole ones, so that's going to be 3/4. The circle on the end is easy to see. That's 3 to 4. And here we have 1, 2, 3, 4 parts out of 6 parts. So that's 2 to 3. So this is the one that's the same. So we would circle that guy. All right, circle the ratios that you can use to form a proportion with. So to form a proportion, they have to be equivalent ratios. So none of these are equivalent to 1/2. And none of them are equivalent to 1/4, but 3/4 and 75/100 is also 3/4. So these two ratios are equivalent, so they can form a proportion. If we did their cross products, we would get 300 and 300. So 3 times 100 is 300, and 4 times 75 is 300. So remember, if their cross products are equal, then we have a proportion. All right, so cross out the proportion that does not have the same solution as the others. All right, so we have to go through and solve them. If we solve the first one, okay, we get 12 times 20, which is 240 equals 17n. All right, that's our cross products. Here, this is going to be 240 equals 17n. So I know these two are going to match no matter what it divides to. And over here, we're going to get 240 equals 17n. So these three are going to match, okay? Because all of the cases I'm dividing 240 by 17 to get the final answer. And this one I'm going to get 340 equals 12n. So this one's not going to have the same answer. So we'll cross them out, okay? All right, vocabulary builder, bisector, okay? Other word form is bisect, that's a verb, so to bisect something. Definition, a bisector divides a whole into two equal parts. So we had an angle bisectors, we've had segment bisectors, okay? So a bisector is a point, a segment, ray, or line that divides an angle or segment into two congruent angles or segments, okay? Use the diagram at the right, complete each statement with the correct word from the list below, and use each word only once. So ray BD is the bisector of angle ABC. It cut ABC right in half, so it's the angle bisector. Angle ABC is being bisected by that ray. Okay. And lastly, BD is the bisects angle ABC. All right, that's each word one time. Okay, let's flip it over and see the new stuff for today. Okay, we have theorem 7-4, the side splitter theorem in its corollary. Okay, so the side splitter theorem is if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So here's our big triangle. And we have a new line that side splits the other one. Okay, so these two lines are parallel and it splits two sides of the triangle. Okay. All right, so it's supposed to split it proportionally. So let's see what that means. So this says if RS and XY are parallel, then XR, which is this length, compared to RQ, which is that length, should be proportional to the same ones on the other side. So XR corresponds with SY, and RQ corresponds with SQ, and that's where they got the SQ down here. So if XR is 4 and RQ is 4, YS is 5, then SQ would also have to be 5. Okay? So these are the same on the left side, then these should be the same on the right side because it has to be proportional. So 4 divided by 4 would make 1, 5 divided by 5 would make 1. So if XR was 3 and RQ was 6, so that's in the 3 to 6 ratio, and YS is 4, what would SQ have to be? Well, this reduces to half, so this one has to reduce to half also, so we know that that would have to be 8. Okay? we have a corollary to this. It says if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. And this just comes from the fact that you could extend these segments and make a triangle out of them. Okay. All right. So A, B, and C are parallel. AB, BC. So AB compared to BC. That's the tall one, the short one at the top two, and the long one for the bottom two, should be the same as the short one over here for the top two and the long one for the bottom two there. Okay. So it also works using like double ones, like AC and AB would be the same as WY and WX. So we have to complete some proportions down here based upon that side splitter corollary. So BC is over here, and AB is the little one up top, and we just talked about that one. So XY, and then the little one up top would be XW. All right, let's mark again. So BA is here, all right, and that went together with XW. And then on the XW side, we were comparing YX. So on the other side, we must be comparing BC. Okay, and then in our last one, AC is the big one from the top all the way to the bottom, and we're comparing that to AB. So over here, we need to compare the big one, WY, to the top, which is WX. All right, so we have a problem with this down below here. Using the side splitter theorem, what is the value of A in the diagram at the right? So we have our triangle, and we drew a new line splitting the two sides in half, or splitting the two sides so that these lines are parallel. Okay, one of the sides of the triangle and the new line we drew. Right. Okay, so we measured 12 and 18 on the right side, and then we don't know these, but we know one of them's 4 longer than the other. So they have the work down here for this. They compared the left side, the top part is A to the bottom part of A plus 4, to the right side. The top part is 12 and the bottom part is 18. All right, so this is using the side splitter theorem. And then we did cross products here. Okay, so 18 times A is 18A, and 12 times A is 12A, and 12 times 4 is 48. Okay, and then we're just subtracting 12A to both sides to get all the A's on the same side. So subtraction, property of equality. And then we got 6A equals 48. So that's simplifying, just putting the A's together. And then we're going to divide 6 to both sides. So this is going to give us division, property of equality. And then when we work out the division there, that's just simplifying. So in this case, we end up with A is 8. So if we go back up here, then we know this is 8, and this is 8 plus 4, which is 12. So if we look at our ratios, 12 to 18 on the right side, that reduces to, let's see, 6 goes into both of those, so 2/3. And on the left side, we had 8 to 12, and that 4 divides into both of those, which is 2/3. So our ratios are the same, just like they're supposed to be. All right, let's flip it over and take a look at page 3. So problem 2, finding a length. This is a camping problem here. So 3 campsites are shown in the diagram. What is the length of site C along the road? All right, so we have 3 parallel lines, and then we have transversals cutting across them. So we have this green transversal and this blue transversal. So we know that that's going to break it into proportional sides, okay? So we're going to let Y be the length of site C along the road. So we'll put a Y here. Okay. Use your justification at the right to find the value of Y. So first we use the side splitter corollary, and that says that Y compared to 7.2, so using this side of this transversal should be proportional to using the other transversal. So 6.4 goes with Y, and 8 goes with 7.2. So since these are proportional, we can set this up. And then we'll solve our proportion. We'll cross multiply. we'll get 8y equals 46.08. So that's our cross products property. And then we'll divide both sides by 8. Okay, so that's division property of equality. Okay, so just divide both sides by the coefficient of 8. Okay, and then we're going to get y equals 5.76. Okay, and then that means the length of site C along the road is 5.76 yards. All right. Down below here we have theorem 7.5, the triangle angle bisector theorem. All right, so if you have a triangle, any old triangle, and you draw a bisector from one of the angles, so we split this angle in half, okay? If you do that, if the ray bisects angle of the triangle, then it divides the opposite sides into two segments that are proportional to the two sides of the triangle. All right, so it divides the opposite side, this one and this one, so that they're proportional of the other two sides of the triangle, this one and this one, okay? So in our picture here, we have that. We have a bisector splitting it. And you can see they're using the split part, CD and DB, these two links here. And they're comparing them to, and this is important, since they put CD on the top of the first proportion, we need to use the side AC on the top of our second proportion. And then the same with the DB. DB was on the bottom, so AB has to be on the bottom. So the sides that are on the same side of the segment that's of the split side has to go together. Okay? All right. This is one you're definitely probably going to want to make a note card and study for. All right, so what is the value of y in the diagram at the right? So here's our angle bisector, cuts through here. So I know that the proportion of these two and these two form equivalent ratios, so it should make a proportion. So the split side is 9.6 and 16, so 9.6 compared to 16, and the 9.6 corresponds with y, and the 16 corresponds with 24, so that should be the other side of our proportion. And that's the triangle angle bisector theorem. And then we could do our cross products, and we're going to get 16y equals 230.4. And then we'll divide both sides by 16 and simplify. So 230.4 divided by 16, that's going to make 14.4. All right, so the value of y is 14.4. All right, so the trick here is to remember when we split that side over here, the two split pieces are going to be, a ratio of the split pieces are going to be proportional to the other sides that we didn't split. But since 9.6 is on the same, touching the y side, we have to put the y up top. And 16, the split part, is touching the 24. We got to put the 24 with the 16 on the bottom here. Okay. All right, let's flip it over. We have a lesson check. So as always, pause your video, try your lesson check, and then come back and see how you did. All right, welcome back. Let's go through our lesson check here. So what is the value of x in the figure at the right? So over here we're given x, this little piece. We're given 10, the other part of the side. Okay. And on this one we're given 45, the whole side of that triangle. And we're given 30, which is part of the triangle. Okay. So if we want to compare x and 10, okay, that would be fine, but we would have to compare it to 15 and 30, not the 45, because the 15 is the piece that corresponds with the x, okay, 45 minus 30. Unfortunately, we don't have any of that in these. So these are the ones that are trying to trick us with the x and 10, so it doesn't work because we don't have the 15 in there. They're using the 45. And 45 is the long one. So now we have to say, okay, well, how are we going to go about doing this? Okay. So we're going to compare x, and we're going to compare it with x plus 10 probably. Okay. So we have x and x plus 10. Or we could compare 10 and 10 plus x, one of those two ways. So let's look at the x and x plus 10. X and x plus 10, this is this comparison. So the short one up top compared with the whole long one over here. So x and x plus 10. Unfortunately, that still needs the 15, so that one's not going to work either. So now we're down to the one that we already know by process of elimination, but let's talk about why it's correct. So the 10 is this length, and that corresponds with the 30, so 10 and 30 are both on top. And then the big length is 45, so that goes on the bottom, and the big length here is x plus 10, so that goes on the bottom. So this is the one that's going to work, okay? Solve that proportion now. So we're going to do our cross products here. 450 equals 30 times x plus 10. And then I'll do the distributive property. And subtract 300 to both sides, so 150 equals 30x. And then when I divide by 30, I'm going to get, let's see, 3 goes into 15 5 times. Okay, so x is going to be 5 long. All right, then our second part of the lesson check down here is a do you understand? So a classmate says you can use the side splitter theorem to find both x and y in the diagram. So y is on the transversal, but x isn't on our transversal. X is that extra segment drawn into the triangle, okay? We didn't learn anything about that. So explain what is wrong with your classmate's statement. So cross out the links that are not parts of the sides of the parallel lines, okay? They're intersected by the parallel lines. So we have the triangle sides and they're intersected by the parallel lines, and we're supposed to cross out the ones that aren't part of it. So we should keep the 2 and the 3, that's the left side, and we should keep the y and the 2.4, that's the right side, but we need to throw away the x and the 7. They don't have anything to do with the sides being split. So can you use the side splitter theorem to find x? And this is no, okay? That's not part of our sides, but we could use it to find y, okay? All right, so explain what is wrong with your classmate's statement, and you could say something like this: the side splitter theorem only works for the side segments that were split. Okay, not for that middle part. All right, so this concludes chapter 7 for us. So check out the vocabulary words that you understand. Hopefully you're pretty good at bisector. You've been doing that one for a while. We've definitely been doing proportion for a while. And the side splitter theorem, you might need to go back and study a little, and you definitely make a flashcard for memorizing this for our test. So if you're not over here, once again, go back, watch the video a little bit, and go through about that. How do you understand side and angle bisectors? What's going on there? How does the side splitter theorem work? Okay, and its corollary. I'll see you in class next time for some practice, and then we'll study for our test.